So let's continue with partial differentiation. Now let me have a question. U equal to e to the power x, y, z. You have to find del 3u, del x, del y, and del z. So you have u equal to e to the power x, y, z. This is 1. This is del 3u, del x, del y, del z. Let me first differentiate partially with respect to z, then with respect to y, and then with respect to x. Differentiating partially with respect to z. You see, u is function of x, y, and z. You are differentiating partially with respect to z. X and y will be constant. So this is del u by del z. It is e raised power x, y, z is as it is. E raised power x, y, z. Then x, y is constant. So this is x, y. Okay, e to the power ax. Derivative is e to the power ax into a. So here a is xy. So del u by del z. Now this can be written as x times y e to the power xyz. Fine. Now you have to differentiate. You have del 3u, del x, del y, and del z. So now let me differentiate this with respect to y. Differentiate partially with respect to y. Let me suppose that this is 2. Differentiate 2 partially with respect to y. This is del 2u, del y, del z. Now x is constant. You have two functions, y and e raised power x, y, z. Derivative of y is 1, e to the power x, y, z as it is. Then y as it is. Derivative of e raised power x, y, z is e raised power x, y, z. When you are differentiating partially with respect to y, x and z is constant. X and z. They are constants. So what remains is that e to the power x, y, z, x plus x square yz. Okay, this is the function. Now let me suppose that this is 3. In order to find del 3u, del x, del y, del z, you have to differentiate this function 3 with respect to x. Differentiating 3 partially with respect to x, we will get del 3u, del x, del y, del z equal to, now you have two functions. E to the power xyz means e to the power xyz. You are differentiating with respect to x, so y and z are constant. Second function is x square yz. This is second function. Now e to the power xyz as it is. Derivative of x plus x square yz with respect to x, it is 1 plus 2xyz, because yz is constant in this case. Now let me take e to the power xyz out. What remains is xyz, then x square, y square, z square, then 1 plus 2xyz. So the answer is e to the power xyz, 1 plus x square, y square, z square plus 3xyz. This is partial derivative of this function with respect to x, y, and z. We have first differentiated partially with respect to z, then with respect to y, then with respect to x. You can, since the function is continuous, you can go either way. You can differentiate partially with respect to x. You can also find x, then z, then y, whatever you would like to find, whatever will be asked. Now, let u is equal to tan inverse y by x. You have to find du. You have seen that if z is function of x and y, then dz is del u by del, or del z by del x dx, del z by del y dy. Or you can also write as, since z is a function of, z is f, del f by del x dx, del f by del y dy. This is it. Now here u is function of x and y. So let me find du. Du will be del u by del x dx, del u by del y dy. This is 1, this is 2. What I have to find is that del u by del x and del u by del y. Now let me differentiate 1 partially with respect to x and y. What I will get, del u by del x, tan inverse function 1 upon 1 function 1 plus function square. Now del by del x of function y by x. This is x square upon x square plus y square. Derivative of y by x with respect to x, it is minus y by x square. Because y is constant and derivative of 1 by x is 1 minus 1 by x square. So is finally minus y upon x square plus y square. Similarly, del u by del y. This is u equal tan inverse y by x. You have to differentiate partially with respect to y. This is 1 upon 1 plus y square by x square. Then derivative, partial derivative of y by x with respect to y. 1 by x is constant, derivative of y will be 1. This is x square plus y square into 1 by x. So this is x upon x square plus y square. Hence from 2 du is equal to del u by del x dx del u by del y dy. This is equal to minus y by x square plus y square dx plus x square plus y square dy, or your du is finally minus y dx plus x dy upon x square plus y square. This is it. This is page 28. Now, let another question is, your x is r cos theta and your y is r sin theta. You have to find dx, dy, d theta and dr. Fine. Now, in order to find dx, what will be dx? This is 1 and this is 2. See, you have x function of r and theta. So dx will be in terms of r and theta only. So if I will write dx, dx will be del x by del r dr, del x by del theta d theta. Because if z is function of x and y, then dz is del z by del x dx, del z by del y dy. Here x is function of r and theta, so you will have del x by del r dr, del x by del r d theta. This is it. Now this is quite easy to find del x by del r. See, del x by del r is cos theta and del x by del theta is minus r sin theta. Fine. Therefore, dx is del x by del r dr minus del x by del theta d theta. This is it. Similarly, you can find dy. Y is again function of r and theta, so dy will be del y by del r dr and del y by del theta d theta. Okay. Now comes theta. You have from 1 and 2. Let me write here. Similarly, find dy. Now from 1 and 2, what is y by x? Is r sin theta upon r cos theta, means tan theta. This gives theta equal tan inverse y by x. So theta is function of y by x, y and x. So you can find d theta. It is del theta by del x dx, del theta by del y dy. This is the question which we have done just now. Theta u was tan inverse y by x. I had found du. Now theta is function of y and x, so I can find d theta. You can always find del theta by del x, which is minus y upon x square plus y square, del theta by del y, which is x upon x square plus y square. This is the same question as I have done here. This one, u equal tan inverse y by x. Here theta is equal tan inverse y by x. So you can proceed and you will get this thing. Instead of du, you will get d theta. Now you have to find dr. See, your x is r cos theta and y is r sin theta. Now x is function of r and theta, y is function of r and theta. So this will be quite difficult. What should be taken as r? Now, if I will add, this is 1, this is 2, as has been written here. Adding 1 and 2, I will get x square, squaring, squaring and adding. X square plus y square equal r square. Sin square theta plus cos square theta. So x square plus y square is equal to r square. So r is function of x and y. So if I have to find dr, then it will be del r by del x dx, del r by del y dy. Fine. So this is quite easy to find del r by del x and del r by del y. From this, say this is a, differentiate a partially with respect to x and y, because r is function of x and y. Here it will be very difficult to find r in terms of y and theta, in terms of x and theta. So here r is function of x and y. I will get 2r del r by del x equal to x. This means del r by del x is equal to x by r. 2r del r by del y is equal to y, means del r by del y is equal to y by r. Thus, dr is x by r dx, y by r dr, or x dx plus y dx dx y dy. This is dy is equal to r dr. This is the relation. This is dr. Fine. Now comes one more question. This was x function of theta, y function of r and theta, r and theta. Now if your x is function of, x is r cos theta, y is r sin theta, this is 1, this is 2, but x and y are, or r and theta are functions of t. Okay, they are not independent. Here they were independent, so dr was like this. Now if x is function of t, y is function of t, means r is function of t, theta is function of t, r is function of t, theta is function, that means x is function of t, y is function of t. So you can always find dx by dt, dy by dt, dr by dt, etc. See, I will just give an example. Not an example, you see, this is x. If I have to find dx, what is dx? I have already found dx. It is del x by del r dr, del x by del theta d theta, because my x is function of r and theta. So dx will be del x by del r dr, del x by del theta d theta. But if r is function of theta, t, r is function of t, theta is function of t, then means x is function of t. So when x is function of t, I can always find dx by dt. This will be dr by dt over here, d theta by dt over here. This article I have shown day before yesterday. So you have three things: del x by del r, which I have already found; del x by del theta, already found. Now you have dr by dt, you can put it like this, d theta by dt. This is actually, in books you can see, this is x dash, written as x dash is del x by del r, r dash, del x by del theta, theta dash. This is it. You can do it yourself. Okay, this is page 28. Now let me take up page 28. This was 29, sorry. This is page 29. Let me take up page 30. Double points. You see, what's the double point? If through a point, say this is a point, if through this point two branches of a curve pass through a point, if through a point two branches of one curve, or say this is one curve, okay, fine. If two branches of a curve pass, then this point is known as double point. Let me write down. A point on a curve is called a double point if two branches of the curve pass through it. Fine. Now, see, if you have a curve and this is the double point, two branches of a curve pass through it, then obviously you will have two tangents on this point. This is one and this is another point. This is tangent 1, this is tangent 2. Okay. Now let me have one more curve. This is the curve. And this passes through this point. This is the point. This is the tangent. This is a common tangent. And this is the curve. I don't know why these two branches. This is one branch and this is another branch. Where these two curves will pass each other. Now, if at a point I have two real and different tangents, this point is known as node. If I have equal or common tangent, then this is known as cusp. And if I don't know where the two branches will pass each other or will intersect each other, then this is known as isolated point or conjugate point. Okay, let me write down. See, since two branches of a curve pass through a double point, therefore there must be two tangents to the curve at that point. Okay, one to each of the two branches. Fine. This is branch 1, this is branch 2, this is branch 1, this is branch 2, this is branch 1, this is branch 2. Fine. Now, this is important. If the two tangents are real and different, just like in this case, these are real and different, the double point is called a node. if the two tangents are real and coincident, then it is called a cusp. And if this is real and different, this is real and coincident. If the tangents are imaginary, because in this case tangents are imaginary, we don't know where they will meet, where they will intersect each other, then the point is known as the conjugate point or the isolated point. Fine. Okay. Now how to find these points? How to find whether a point is a node, a cusp, or a conjugate point? That will be done. And then how to find see that whether this is a node, a cusp, or a conjugate point, means nature of, to see the nature of double point. We use the formula del 2f del x del y whole square minus del 2f del x square del x2 into del 2f del y2. If this is positive, then this is a node. If this is 0, then this is a cusp. And if this is less than 0, then this is an isolated point or conjugate point. This is actually discriminant of certain b square minus 4ac. 4 goes, this is b square minus a and c. If this is same, just like in quadratic form, if this is positive, then you have real and different. If this is equal, then equal to 0, then it has two equal roots, and this negative means then imaginary roots. Page 30. Page 31. Now, you see, what is the equation of tangent? Ax plus b equaled 0. Okay. In asymptote also we have taken the equation of the line as mx y equal mx plus c. So now ax plus b equal, let me write this one. Now ax plus b equal to 0 means either x is equal to minus b by a. Fine. This is okay. Now ax plus b equal to 0 means both a is 0 and both a and b are 0. Then and only then ax plus b is equal to 0. Similarly, when you have z as function of x and y, and you have to find dz, or let me write, you have z, let me write this function fxy equals 0. These are two functions, x and y. If I have to find dy by dx, but in terms of partial derivative, what is that? It is del f by del x, del f by del y. This I have shown you. If you don't remember this, let me show it again. If your z is function of x and y, then I have shown that dz is equal to del f by del x dx, del f by del y dy. But if this z is constant, then dz is 0, and I have del f by del x dx plus del f by del y dy is equal to 0. This gives me dy by dx is equal to minus del f by del x upon del f by del y. So if I have to find equation of the tangent, then this is See, this gives me, this is dy by dx tangent, this gives me del f by, this is del f, del f by del y, del f by del y dy by dx plus del f by del x equals 0. Now see, del f by del x must be 0. In order to have this equation ax plus b equals 0, I must be having del f by del x equals 0 and del f by del y equal 0. This gives me the points. If those points satisfy the given equation, then those are known as double points. For example, if I have say let me take one question from some exercise. See, you have x cube, find the position and nature of the double point. For the curves, let me have this curve 4y square equal x square 4 minus x square, or you have 4y square 4x square minus x4, or x4 plus 4y square minus 4x square is equal to 0. This is function of x and y. 4x x4 4y square minus 4x square 4 equals 0. This is a function of. Now let me find del f by del x. What is del f by del x? It is 4x cube minus 8x. Del f by del y, it is afy. Now del f by del x equal to 0 means 4x cube minus 8x equals 0, means 4x x square minus 2 equals 0. So this gives x equal to 0, x equal plus minus root 2. Similarly, del f by del y equal to 0 means 8y equal to 0 means y equals 0. So the possible double points are x is 0, y is 0, x is root 2, y is 0, x is minus root 2, y is 0. You can see this is my question. If I will put x equal to 0, y equals 0, so 0, 0 satisfies this equation. Now if I will put y equal to 0, left hand side is 0, and x equal to root 2 square is 2, this is not 0. If I will put y equal to 0, left hand side is 0, x equal to minus root 2 whole square is 2, so this is not 0. So since 0, 0 satisfies 1, therefore 0, 0 is the only double point. अब नेचर निकालने के लिए, to find the nature, you see this is the given equation, this is del f by del x and this is del f by del y. I need to find all these things. I need to find del 2f del x del y, del 2f del x2 and del 2f del y2. So let me differentiate 2 and 3 partially with respect to x and y. Let me differentiate 2 and 3 partially with respect to x and y. Now this is del f by del x. What is del 2f del x2? This is 8x square minus 8. Derivative of del f by del x with respect to x. It is 3, 4, 12. Sorry. It is 12. 12x square minus 8. Del 2f del y2. This is del f by del y, so it is 8 only. Now del 2f del x del y. This is function of x. If you differentiate this with respect to y, its value will be 0. This is function of y. It is, if you will differentiate this with respect to x, its value will be 0. So del 2f, this will be 0. Now to find the nature, del 2f del x del y whole square minus del 2f del x2 del 2f del y2 is equal to 0 minus 12x square minus 8 and 8. The point is nature. You have to find the nature at what? The origin 0 0, which is the only double point. So your x is 0, y is not there. So this is minus minus plus 64, which is greater than 0. Thus 0 0 is a node. Fine. Question is fxy equal to x raised power 4 minus 4y cube minus 12y square minus 8x square plus 16 equal to 0. This is equation of the function fxy. I have to find position and nature of the double point. First of all, in order to find the double points, I have to put del f by del x equal to 0 and del f by del y equal to 0. I will get the possible double points. I have already talked why this should be. These two are 0. Then if you find the double derivative of ax plus b or del f by del y dy by dx plus del f by del x equal to 0, second derivative, you will get a discriminant, which is that is used for finding the nature of the double point. Now let me find del f by del x. It is 4x cube with respect to x only minus 16x. This is with respect to x. Del f by del y 12y square minus 24y. 4 3 12y square 24y. Del 2f, let me find it over here only. Del 2f del x2 4 3 12x square minus 16. Del 2f del y2, it is minus 24y minus 24, and del 2f del x del y is equal to 0. If you will differentiate this partially with respect to y is 0, partially with respect to x equals 0. Now to find double point, the double point, put del f by del x equal to 0 and del f by del y equal to 0. Now del f by del x equal to 0, this is the method, Del f by del x equal to 0 means 4x cube minus 16x equal to 0. Means 4x into x square minus 4 equal to 0 means x equal to 0, 2 and minus 2. Del f by del y equal to 0 means minus 12y square minus 24y equal to 0 means minus 12y y plus 2 is equal to 0. This gives us y equal to 0 and y equal to minus 2. So the possible double points are see, your x is 0, y is 0, x is 0, y is minus 2. X is 0, y is 0, x is 0, y is minus 2. This is 1. Then now x is 2. X is 2, y is 0. Then x is again 2, y is minus 2. X is 2, y is 0, x is 2, y is minus 2. Then third one, x is minus 2, y is 0. And X is minus 2, y is minus 2. X is minus 2, y is 0, x is minus 2, y is. So there are 6 points, 6 possible double points. But out of these, only 3 points satisfies equation. You can see which of these. See, if you, I will take first one. X is 0, y is 0. See here. X is 0, y is 0, you will get 16 equals 0. Means this doesn't satisfy. Okay. You can see which point satisfies and which point doesn't satisfy. Let me take this one. X is 0, y is minus 2. See, x is 0. This thing goes, this thing goes. But y is minus 2. Y is minus 2 whole cube. Minus 2 whole cube is minus 8. Minus 8 into minus 4. How many? 32. Y is minus 2. See here. Y is minus 2. Minus 2 whole cube is 2 into 2 into 2. 8. Minus 8 minus here. So minus 4, 8, 32. Now y is minus 2. Minus 2 whole square is 4. 4 into 12. 48. Now x is 0. Y is 16. See, this is 48 minus 48 is 0. So this satisfies it. Similarly, you can see that this doesn't satisfy, this doesn't satisfy, but this satisfies it. Minus 2 and 0 satisfied it, and 0 and minus 2